Listen-only mode.
Hi everybody, welcome to the Dynamo for the Real World webinar. I'm Glenn Sinclair, a Technical Consulting Lead here with A2K. So today we're going to go through a little bit of an intro first up to A2K and myself. Then on the Dynamo side we're going to have a look at what it is, what is actual Dynamo there. We're going to have a look at some practical applications of how it can be used. We're going to have a look then at using it with an abstract data set that I've prepared, then move into a bit of an overview of a different product called Autodesk Vasari that we can use to do some environmental analysis. Then you'll look at using those environmental analysis results in Dynamo for building optimization. And there will be time for questions at the end. So if you do have a question, feel free to pop it into the questions box in the Citrix control panel there. So A2K Technologies, we're the largest technology partner in Australasia, so over 150 staff there. So if we don't have someone nearby to you in your state, we're not afraid to fly someone out to come and talk to you. We don't just do Autodesk products, we do, as you can see there, a number of other products, including HP and Microsoft. So if it was something that you were interested, we would be able to provide you with the hardware, an HP workstation with Microsoft Windows already installed, and potentially the Autodesk and Adobe suites pre-configured if that was something that you needed. So we don't just do hardware and software, we do a lot of training, as you can see there, and a lot of consulting work. And we've got a great support team there as well, always on standby. So myself, working as a technical consultant with A2K, my background is as a BIM manager, majority of that time with Woods Bagot. So speciality is in the large project establishment and managing the BIM within the Brisbane and Melbourne studios. So I started off residential drafting, some very small, on the smaller side of the projects, and moved through to some very large projects over in their Dubai studio there. Alright, so on to Dynamo. So what is Dynamo? Dynamo is a visual scripting language. So we can use it to, we generally are using scripting to automate tasks for the computer, so that we don't have to manually sit there potentially and enter numbers and data. We can automate tasks using a scripting language. So Dynamo, as I said, is a visual scripting language. So compared to a traditional text-based scripting language where we are typing in certain commands and having the results, a very simplified example off to the left there of adding 2 and 5 together. And the result would be displayed in this little VB script over here. On the right we've got the example of a visual script. So we've got the little batteries there with the numbers in them, both being fed with wires into this little addition battery, and that's being fed into the one that is just displaying our little result. 2 plus 5 is 7 there. So what it does is it removes the entry barrier into the scripting realm. So with traditional text-based scripting, it's very precise with the syntax that needs to be used. So different languages have different syntax, and so all of the commas and potentially brackets and semicolons need to be in exactly the right spot for that script to work correctly. So just one little bracket out of place can really put you off and cause the entire program not to work. So with visual scripting, we're plugging the outputs of the number battery into the input of the addition battery. So it's very visual and very simple to do so, and we can't go too far wrong, and there's no syntax that we need to worry about there. So very low, easy entry into being able to script things. So what is Dynamo? So on the visual scripting is not a new thing. It's out there. It's quite common, and a number of different areas that is being used to, again, break down that barrier to entry is the Android app creator, which was originally done by Google themselves, is now being worked on by MIT. Enables you to create your own app for the Android platform. So you see there the little receiver there is on the black button click action. The thing to do is draw the canvas a paint color, and the paint color is black. So by plugging those modules in, you're creating an action for the phone to do. Another really common, obviously, scripting language, visual scripting application is Grasshopper for the Rhino platform, which is shares a lot of similarities with Dynamo. But there are other examples as well, like in 3D Studio Max now, the new Slate material editor also works with visual scripting to simplify the process of applying maps into materials. So it is an open source software, and it's in a strange spot. It's an open source software that has a full-time team actually at Autodesk working on it. So it is open source, which is great, and it does in fact run independently of Revit if you wish. So it does with the newest version, 0.7.2. It installs as a standalone application that can be run from the Start menu to process any data independent of Revit. But the way that we're going to be using it and demonstrating it today is in the Revit platform, and by opening it as a Revit add-in inside of Revit, we get the hooks into the Revit API that we can start to manipulate geometry and whatnot. So it was started by Ian Keogh, who was with Bureau Happold at the time, and then he was moved over to Valor Systems, who were acquired by Autodesk. So he's now there at Autodesk, so the basics apparently of the first inception of the platform is that we should be able to teach Revit to do computational design in the same way that Grasshopper can drive Rhino. So it's not a Grasshopper clone, it does work in a different way, but it's trying to achieve a similar result to drive geometry with data and with scripting there. So on the what is it side, did a bit of a Google search for visual scripting and whatnot, and this is the sort of result that came up. So this is commonly associated with Dynamo guys. The guys that are working on it are doing a lot of really interesting, awesome form creation things with Dynamo, but this probably won't be the first thing you do in Dynamo. Well, I hope it's not the first thing you try to create in Dynamo is a big, trippy, crazy, curvy form like this. So we got to best off to start simple and start with something small and build up to complex form creation when we understand the tool. Additionally, this may not be the type of project you get to work on every day. The big twisty towers and whatnot. That would be a lot of fun to work in one of those firms, but the majority of us unfortunately don't get to parametrically create geometry like this every other day in the office. So what I've called this presentation is Dynamo for the real world, just talking about practical everyday examples that I've used in industry and that I've come up with since that are just everyday automation tasks within Revit that we can do with the Dynamo platform. So Dynamo is all of this that you see here, but what I'm going to be covering is the more practical aspect of it. So I'm going to jump into live demonstration side of it all. So let's hope this all works. So I've got the Revit open here, and I'm going to come into the Dynamo add-in here, and I'm working in the slightly older version, which was version 0.6.3, which is where all my workflows were developed. They have recently updated it to the 0.7.2, which is a lot more stable and quite a great, huge update, a lot of improvements, but it did cause some of the older scripts not to work anymore. So I'm going back to one version there. So in the little interface here, I'm not going to go through a full tutorial. I'm just going to describe some of the basics. We've got the commands over to the left that we can browse through the commands to find something in the core of Dynamo about lists. We can browse through the command list here, and so things to do with Revit, they are separated into categories there. But the easiest way to get started with commands is to type as the search for the first few letters there. So if it's a number that I'm looking for, I type num and I get the number battery there, and also anything else to do with number comes up in the little search list. So very intuitive, very easy to use there. If I'm looking to do something with a list, if I type list, I can see that I can create a list. I can do a few other bits and pieces with lists there. So that's quite good. By clicking the command, we're going to create that battery out in the workspace to the right. So if I click it again, I've got a few numbers. Again, to get the same thing, I can do a little copy paste with the keyboard to get the same result there. So over to the right here we have our sort of scripting interface, and when I'm working in Dynamo, I'm generally working backwards from the end result. So if I at the moment want to create a point in the file, I'll generally start with the point and then look at what inputs that point needs to be created. So a point is an XYZ coordinate in here, and so generally I would have started with the XYZ and then looked at so what's this looking for? Okay, it's looking for an X, a Y, and a Z as a number there. So to feed this info, the number 0 into the XYZ battery, we wire the 1 in there. So I can click on the little output and wire it into the XYZ. So I could have that same number going into all three, or a different number into the X, Y, and Z coordinates there. We're going to do one of these. So again, just when working in Dynamo, it's just going to appear over the top of Revit. So if I click in the background here, you'll see that Dynamo does not behave as if it's a separate application by docking in behind. It always shows above the Revit interface. So what I generally would do is maximize left and maximize right the two platforms, so I can see my Dynamo to the left and my Revit to the right here. So I've wired up a very simple little command here to create this XYZ point. To actually action that within Revit here, what I need to do is actually hit the run command down here. So when I hit run, it will create that. My little number 1 is going to freak out. First gets put in, that's nice. When I hit the run there, it actions that command. So you'll see in the background there, we've got the preview window with a dot created, and my X, Y, and Z has now created that output, which was the X, Y, and Z. So I can hover over below here and actually select that to see the X, Y, Z coordinate, 0, 0, and 1. And I can also see it has been created there in the background. So there is the background there is a preview of the current workflow. I hit Alt G or Control G. I can actually navigate that background preview rather than the Dynamo script. So as I zoom now, I'm zooming in on the grid in the background rather than the actual script there. Okay, so that wasn't a huge operation that we did just there, creating a point, but just starting simple with creating this little spot here. So to actually get into a task within Revit, what we're going to do is place a piece of geometry. So we're going to place a family. So if I start typing in here family, I've got a number of options, and what I want to do is create family instance. So here, my create family instance is looking for 2 inputs. It's looking for my XYZ, which I have. Thank you. And it's looking for the family type. So again, if I look down inside of my family search, I've got select family type as one of my options here. So this is where we start to look at the hooks that it has into Revit. So well, let me show you first. So now that I've added the select family type battery here, if I select in the drop down, I can see every single family type that's inside of the Revit project. So that is everything that I've got inserted so far. So the one that I'm looking for is my seat. So I'm going to create a seat family, and I'll wire that into the create family instance and hit the run button. And off to the right, we have a seat created in the project there at the 00 point of the file. So that was a fairly simple little operation. I can now move that object by changing the numbers, obviously. If I move them around, I can move the seat around in the file there by hitting run each time. That's a little laborious, coming down and hitting run each time. So what we can actually do is have this run automatically option ticked on, and that means every time I make a modification in the script, it will be applied in the Revit file automatically. So that's something that's really powerful when we're dealing with data sets and numbers, and you'll start to get used to having that turned on once the Dynamo script is shall we say, stable. So you can get yourself into trouble by having this run automatically ticked on, and if you're halfway through trying to do something, it might potentially crash Revit if the data inputs are not complete. So generally, you might untick the run automatically, make the changes, particularly when you're dealing with Revit geometry like this, then tick it back on once you're happy with the changes. So a visual scripting demo wouldn't be complete without showing the number slider. So this is another little battery that rather than typing in a number, I actually wire in a little slider here, which is going to move the chair as I slide the little slider from left to right. So you see there over onto the right, my chair is behaving itself, moving along. So at the moment it's set to go from 0 up to 100, put that down to something like 20. Now the maximum value is 20 or so. So off to the right, we've got our chair moving in Revit, just changing its location there. So I'll just delete that little number module there. So as I mentioned, we're using visual scripting to automate repetitive tasks and to make the computer do the heavy lifting and the hard work here. So what I've just done there is place a chair, a single chair. That could have potentially been done manually a lot faster. So what we'll do now is look at something that might be a little harder, which would be to place a grid of chairs, so a number of chairs in a grid pattern. So if I activate the next little module here, and add a grid, so an XYZ grid, what we're going to do is, rather than feeding in a single point into this create family instance battery, we're going to feed in a number of points. So those XYZ points are going to be, it's going to be a list of XYZ points that are coming out of this module. So I've added the XYZ grid module there. I'll take that off for a second while we're the run automatically while we're in here. So well, I'm going to have a look at the inputs that this needs here. So I'm going to reuse my little number slider over here, and it's going to come into my number of objects in the grid for X, Y, and Z. I'm going to leave, I don't want a 3D grid in there, I'm going to leave my Z set to 1 count there. The next object that we're going to need, I'm going to just copy pasted that, get rid of that there. We're going to then enter in here the start point of the grid. So I'm going to just that can start at 0, 0, 0 coordinates, and then the next object that we need here is our XYZ spacing between the objects. So again, I get a couple of numbers and wire those in, and I'm going to leave that at 0. So my X and Y, I'm going to go into the scaling issues in a second, but I'm just going to set that to 3 for now. In my number here, so the spacing in the Z-axis is actually going to be 0 there. So I've got all of the inputs wired here. Can hit run at this stage and have a look at that list. No, I can't. Why isn't that happening? Oh, 0. X and Y count are set to 0. So if I put that up to 7, that might complain. No, that's fine. Must have rounded it down. So I can have a look in the background there now. I have a grid of points rather than a singular point. And in my list, in my output, sorry, my little XYZ node, I have now a list of points. So not just one point anymore, I've got a list of XYZ points. So what I'll do is wire the XYZ points into the create family instance to create chairs in that grid pattern. So there we have our chairs created in Revit there in that grid pattern in accordance with the points that you can see in the background in Dynamo. And so yeah, so we're feeding in a list of points, not just a singular point into the module here. So yeah, reasonably okay. And you'll notice the XYZ space here, I've put in a 3. That's a bit of a bug with the older version of Dynamo. The older version works in feet, so we generally, obviously here in Australia, work in metric and millimeters. So if you were wondering, the conversion from metric to from feet to millimeters is to divide by 304.8. So yep, happen to know that off by heart after doing it a few times. So I'll run a little mathematical battery here to divide the number that I'm putting in by 304.8 and then feed that in here. So then if I turn this into millimeters, so let's go 900 millimeters and hit run, we should have these chairs, put a dimension on, exactly 900 millimeters apart. So this is in the older version. In the newer version, 0.7.2, the units within Dynamo by default by Revit are meters. So that's great. We can just put in 0.9 and that'll do the same. So yeah, that was a slightly repetitive task that might be worth scripting. But now that we've got this Dynamo set up, obviously I've got this number slider here for my number of chairs. So I can continue to decrease and increase the number of chairs in the grid there. I won't go too crazy, it might crash. 20 by 20 should be okay. You can see as I'm playing around with the little slider here, the number of chairs is increasing. So that might be something that we would actually want to script potentially. So that is a little on geometry creation. I'm going to get a little bit into modifying some existing geometry now. So I'm going to show you a wee workflow that I picked up as a little idea at the Revit Technology conference in 2014 that was held there in Melbourne, looking at a project that a client had in Sydney there, and it was a crikey, this is getting a little slow today, it might be the recording. And they had an auditorium of chairs that had a radial pattern to represent the colors of the chairs. So there was a radial pattern around a number of chairs that were the first ones were green, and I believe the next ones were a lighter shade of green and a radial pattern. And I thought that would be an excellent chance to use Dynamo to modify that geometry. So what I've created here is a pretty ugly little example of an auditorium with a chair here that I have added a little bit of smarts to. So I've just used this standard chair out of the box and nested some different cushion colors inside of it. So they're controlled with this little integer here as an instance parameter, that when I put that to 0, the chair turns red. If it's set to 1, the chair turns, what is it, green, yep. 2 is blue, I think. And then obviously the 3 is the white chair. So the real power of Dynamo here is using it in conjunction with the Revit family. So here I've got the Revit family actually doing all the heavy lifting with nested colors and things, and all I'm going to be using Dynamo to do is just to change this single integer here from a 0 to a 1, for example. So I'm going to show you the little script that I created to do that. Am I going to write that live? No, I'm going to just run through the actual script there. It takes a little while to actually write this one, so I'm not going to sit there and start from scratch. I'm going to open the one that I already have written here. So I'm going to hit open and go to my little script file here. So what I'm going to look at is modifying the chair colors based on an attractor. So I'm going to show you a little bit of this Dynamo script. So what I'm doing here is selecting the families within the project, which is my seating family, and then getting each of those instances, and then I'm querying here in this battery the instance location. So I want to know the XYZ where each of those chairs is in the project. So that's going to be a full list of all of those chairs. Then over here I'm selecting a an object as what I'm going to call the attractor. So I've already got it set, but using this select family instance, I just click here and then select the family that I'm going to use as the attractor, which sets it to that family instance. And then I'm going to get the XYZ of that attractor and then compare the two. So I'm going to compare that list of XYZs against that one XYZ. So what that's going to give me is a list of distances between every one of these chairs and my little attractor post there. So it's going to give me a straight line distance to each chair. So then what I'm going to do with that list down here is to, first of all, I sort the list, so highest to lowest, so that I can subtract the highest from the lowest. So I get the first, which is going to be the lowest. I get the last, which is the highest. Subtract one from the other to get the range within the list. I then divide that list into 4 parts. So I'm going to have the quarter of the chairs that are the closest to the attractor being a certain color. The next quarter of the list are going to be a different color, and then the last quarter and the fourth quarter are obviously going to be the other colors. So what I've just done is divided the range of the list into 4, and so that number, whatever that value is going to be my first quarter mark. That plus itself is going to be the second quarter mark, and plus itself again is going to be the third quarter mark in the list. Then what I do with those values is I rationalize those values. So I've created here just a little formula module here. So these are really powerful, and what I've done is added a nested if statement in here, and this is really great that it uses the same formula syntax as in when you're creating a Revit family. So this is the same if statement that I would put nested into a Revit family potentially. So if we know Revit families, we can really work with Dynamo in a very powerful way. And quite easy to use. If I start typing a variable, it comes up on the left as a battery that I can plug into. So I'm saying that based on the list of distances, if that distance, there we go, list of distance, if the distance is less than the first quarter, then I want 0, which is going to be my red chair. If the list is less than the second quarter mark, then I want it to be 1, which was, what was that? Green. And then else, if it's less than the third, then I want it to be blue. And lastly, if it's none of those conditions, which means it's over the third quarter mark, then I want it to be 3, which is going to be my white chair. So set all of that to feed that 1, 0, 1, 2, or 3 into this awesome little battery here, which is set element parameter. So that is how I can change the value of each of these chairs to a 0, 1, or a 0, 1, 2, or 3. So the element in my list of chairs, the parameter is the little color parameter that I put on there, and the value is the values from the list there. So when I click the run button, it all works and doesn't crash, which would be just great. It's going to calculate the distance between those chairs. Yes, it has worked. It doesn't potentially look like it, but it's now colored in the chairs there. So the closer chairs are red, the next are green, next are blue, and the last ones there are left to be white. So I could be moving my little attractor around and clicking the run button every time, but I don't potentially want to be doing that. So I can, in this case, use the run automatically option there, actually minimize Dynamo, just start to work only in Revit, and as I move the little attractor around, you'll see that it's going to recalculate each time I move it. So if I move it into the center of the chair grid, it's going to create a circular pattern, and so on. So the closest chairs are the red, then the green, then the blue. So that was that first little example. I sort of thought, what else could we do with these chairs, and came up with another little fun example, and that is to, rather than using the distance to the chairs, actually going ahead and using an image. So very powerful. Another little tool within Dynamo is to read a JPEG, and we can slice that up, if you like, into, whoops, I still had run automatically turned on, so I've just given a little spoiler there. So it's going to divide this image up into 50 by 26 grid, which is how many chairs there are, and give me the brightness value for each of those points. Then I'm feeding that through a similar system, feeding that into the the object there, and what I get is the chairs coloured in, if you like, or patterned in the same way as my image file there. So a fairly simple swirly pattern, some black and white. The red ones there, obviously it's a grey, it's a half pixel halfway in between. So I'll start to speed up a little bit now, 12:30. So I looked at a couple of other patterns that I could do there. A zebra type pattern as I load in the image. It's going to read the image, apply the pattern to the chair family. See there my little zebra pattern. And then the last ultimate sellout there, throw the A2K logo on there and have a look at the so reading the image, applying that to those chair objects. So just changing that instance parameter to a 1, 2, or a 3. So yeah, that was just a pretty simple little exercise in Dynamo. Once it's set up, pretty easy to use. And as we've seen, it's the chair that's actually doing the heavy lifting there of having the color parameters nested in. So I'm going to move on now to another little Dynamo workflow that I've used. So that was to, and I'm actually going to close that to save some RAM. So that was an exercise that I've done to visualize an abstract set of data. So in this case it was a skills survey assessment. So we had run a self-assessment on the studio asking name, skills in Revit as a 1 to 5 value, and number of years post-grad experience as a 1 to 5 value. So 1 being 0 to 2 years, 2 being 5 to 10 years and whatnot. And so what we did with that data is looked at a way to visualize it through Dynamo. So I just attended the BIM Day Out conference here in Perth. I happen to be Perth at the moment. And so what I did, being a bit cheeky, was actually to get a list of all of the speakers that attended the event and put a random number in Excel. So using the random function, drag down and put a random number in the column there to simulate that survey assessment. So we've got the names and the numbers here in a CSV file, so comma separated. So they are completely random. You can see there my name. I have a 1 out in Revit. I hope I'm not that bad. So if I close out of that file, that's the data set that we're now going to look to work with. So we can work with that in Dynamo. And what we're going to do is load in that set of data and look to... so actually what I'm going to do here is between working with these two files, I'm actually going to close Dynamo off and run it again as the add-in. So that's going to associate this Dynamo session with the current file in the background there. So that's just something important that you get used to doing there. So I'm going to open up the little one I prepared earlier. And so what I'm doing in this Dynamo script is taking that CSV file, reading the contents, and then turning those into a list by splitting by a comma. So it's a comma separated value file. I then do a couple of operations on that list and work to create a grid of points and place a family on those grid of points, which is a family called building. And so the end result, ideally, when I click run, is going to be a master plan city created through Dynamo, where every tower in the city represents a person within the studio, and the height of the tower, so it's just got some basic instance parameters on it, there we go. The height of the tower represents their number of years of, their skills in Revit, so 1 to 5, and the width of the size of the tower represents the number of years of post-grad experience. So you can see there we've got our little master plan city here of the speakers at BIM Day Out. Again, not real results. I know that these guys are experts, but I just used some random values on there. Sorry, Andrew. I know Andrew's one of the big ones. Danny, I know you're more experienced than that. So, yep, it's just a random data set. But so this was a really great way just to represent the data of what the studio skills were like at that point in time, and very easy, obviously, to do so just by hitting the Go button in Dynamo. Then, so taking that a little bit further, so you see there, I'm just getting values here and assigning them into the towers. To take that a little further, we actually looked at the training plan for the studio, and then looked at, all right, so based on the training plan, next year's values, this is potentially what the city is going to be looking like next year. So here is the growth of the city, if you like. So is that healthy growth? Do we want to strive for more, and things like that? So just communicating data in a language that the management's familiar with in the master planning sense for an architectural firm. So that was a bit of a fun one there. The last thing that we did was actually looked at mapping the towers or the buildings here onto the studio seating plan, and that was an interesting exercise as it demonstrated a sort of concentration of tall, skinny, fresh grads that were great in the software, and then the areas in the suburbs, if you like, of the shorter, wider towers of the guys with lots of industry experience. So it sort of brought up the conversation of, well, do we want technology hubs over here and experience hubs over there, or do we want to mix it up so that the young guy out of the young Revit Pro is sitting right next to someone with experience in the construction industry or architectural there. So yeah, really great conversations. It's just an interesting way of visualizing that data. So the next little product that we're going to have a look at is Autodesk Vasari. So I'm going to run through just a very quick overview of what that actually is before I go too far into it, in case you haven't seen it before. So it is a mashup, I suppose, of Autodesk Revit and Autodesk Ecotect. So Ecotect was a product developed by Andrew Marsh, WA local, that was for environmental analysis, and that was brought by Autodesk and has now been, the features of that software, some of the features have been integrated here into this product called Vasari. So it's a great little product, and it opens Revit files natively. So what I'll open there is just an RVT file straight from Revit. For the analysis side, it only deals with mass objects. So I've got here a massing tower in this little city. So yeah, we need to be dealing with mass, so not walls, roofs, and floors, only with mass objects. So what I'm going to do is, what we can do in Vasari is, rather than just running, say, a basic a shadow study, we can actually run a solar radiation analysis, which is calculating the actual kilowatt hours of energy hitting that surface, in this case, over the entire year. So we can set that to look at a certain time of day, but much more powerfully, we can have that as a cumulative solar study over the entire year. So I'll change that to kilowatts there. So that's quite powerful in itself, and we can visualize that. So we've got the yellow areas are a lot of solar energy, the blue areas are little solar energy, and there is a little graph that sometimes hides itself down here. So we would generally not in industry there producers with the numbers. We would generally just use it as a comparative analysis that before our shading solution it was yellow, after the shades have been applied, ta-da, it's blue. But what we can get out of this is also data. So I can have a look here and I can actually export these analysis results. So if I come in here, I'm just going to export this little CSV file of the analysis. So that's going to split the surface up into a grid and export those results as an analysis there. And I can also have that automatically update potentially. So I can now be making changes to the geometry and seeing the tower in this case update those results. So I've just created this. Again, heavy lifting is done in a Revit family. It's got a rotation parameter on it, so when I change the 10 to 10 degrees, it's going to rotate around by 10 and rerun the results there. So I could manually sit here and type in those numbers, but I want to analyze every single degree between 1 and 360. So let's look at a way to script that, and let's use Dynamo since it's so easy and awesome. So I'm going to start up Dynamo and show a wee Dynamo script there that I've done to do that. So this is to optimize the form rotation based on its insolation value. So it's the solar energy. So I'm going to run this first and then go through a little bit of a rundown of how it works. but I've got this Vasari file here ready to automatically export the results, and in Dynamo I'm reading those results. So the end user might look at this and choose to increment the tower. So I'm going to test every 10 degrees from between 0 and 120 degrees there. We don't want to be here all day. And then for myself, I've done this little reset button here to reset everything, and fingers crossed, when I do tick run automatically and run, the Dynamo script is going to drive that Revit file, and you can see off to the right it's going to analyze every 10 degrees between 0 and 120, and it's going to report those results back so that I can see them. But then it's going to find the optimum resolution, the optimum rotation, sorry, and rotate the tower to that position, whatever that may be. There it goes. So it has done its little rotation. I'm not going to, this did get a little scribbly with the Dynamo script. Don't be scared of that one. But we can see there everything it did. So from 10 up to 120, and I've just output a little, I used a colon separated value inside of a CSV, comma separated file. Anyway, so we've got this little watch here. So it decided that 20 degrees was the most efficient angle, because the total solar radiation hitting all four sides of the facade at 20 degrees over the full year was 195,000 kilowatts. But again, I'm not really reading too much into the number. I'm just saying that that's the most. So 20 was the most optimal, 30 was pretty close behind, and then 40 was the third most. So I might run that one more time between 20 and 30 degrees to get the absolute best result that I can there. Wherever we were. Over here, I will untick my run automatically. I'll reset the file there, which is just something I've done. So every 1 degree between 20 and 30, and run automatically, go. So that will start at 20. It's going to give 10 iterations and test that for me. So you can see it's very powerful that I'm not having to sit there and type 10 of these iterations and use my calculator or use Excel to calculate these values. We're really using the Dynamo software to do the heavy lifting for us and sort that out. So there it went, tested 21 to 30, potentially should have done from 19. And it just decided that 21 was the winner there. So it set that rotation to 21-ish. Oops, something wrong with my rounding there. But so yeah, that was that little exercise. I'm not actually going to run through everything I did here. I may attempt to tidy some of this up and make it available as a Dynamo file on maybe on my blog potentially. So that was a good little workflow looking at a data set created from Vasari and using that to optimize the building form there. So this is a nice little situation where we could be, if we get the choice to be able to influence the form of the design so much as to rotate the entire tower, if we have the freedom to do so, potentially only on a campus site or something like, in this case, just the tower, not the podium. But a more, potentially a more common situation might be, and this is my next little workflow, where we cannot rotate or change the entire form of the building, but we can influence the facade of that design. So I've got a similar file set up here of a form that potentially can't be rotated around in the same way. The form may be set by the powers that be, but if we're dealing with the facade, we can still look to put the optimum facade on that form based on analysis results. So this next little Dynamo script that I'm looking to do works on the solar analysis results of just one face at this stage. Start Dynamo up here inside of Vasari and open up my facade based on insulation. So what I'm going to be doing is creating from Dynamo a curtain wall facade system, and I'm going to be modifying a parameter that I popped on there called shade depth, which is the solar shading of each of the panels within the curtain wall. So I've created that actually as a 4-point adaptive component, which gives me the flexibility in Revit and Vasari to just click where I want the 4 points rather than being confined. So if I think I did 1, 2, 3, 4. So that's a very flexible little component that I'm going to be using. And this, again, component is doing a lot of the heavy lifting in Dynamo. I'm going to be controlling where those 4 points are. And then this little parameter here called shade depth. So 200, 400, yeah, so it's just instance-based parameter to control the depth of the shade above the window. So it's going to be set up like that. Delete that. So what I did in Vasari, I come here and run the 1 year solar study on this guy, and this time we'll do a single face. So I'm just going to select just that face, and it's going to run that calculation. Then I'm going to export those results here as just the north face. Thank you. And so I don't need to actually run that over and over again. So I'm going to actually just delete that analysis result there. So then in Dynamo, I am choosing that face. I'm dividing it up into a grid, a UV grid, getting the XYZ points within the grid. So I've got it divided up 19 by 18 pattern. Then doing some other operations here, creating the 4-point adaptive panel on each of those points, each of those 4 points. Then down here, I'm comparing the results from my solar analysis to each of those points from the curtain wall. So in the solar analysis, it does it by a grid as well. So I'm finding the closest analysis point to my curtain wall grid, and then basing the depth of the facade shade on those analysis results. So again, I've done my rationalization of the list. So I've just got the high, medium, and low. So the areas of high solar radiation, which is the yellow areas, we'll get a 1200 deep sunshade. The areas of medium, so those are the red colors, we'll get the 600 deep sunshade, and then the blue areas we'll just get the little 200 sunshade there, if everything works. So I'll hit run here and let that think for a little, and in the background there should generate that facade on the face and automatically set the instance parameter value of shade depth to the optimum there. So we're not wasting materials, creating a deep 1200 millimeter deep sunshade on every single curtain panel, but we are positioning the ones that are 1200 deep based on analysis results. So if I zoom in here, it's a little hard to see, but you'll see the ones down in this area have got the deeper sunshades set to 1200, the ones in the red area there set to 600, and then right down in the back corner here, the ones are set to the 200. So that was our blue area there. Potentially I should have left that analysis result on there. Leave that on. That is okay. Thanks, Revit. Vasari. So there we go. You can see the results there. That yes, in the yellow areas we do have the deep shade. The reddy areas, it's the medium of 600, and then in the blue areas down here, we are looking at the 200 deep shade. So yeah, just basing that that on some real results, not just aesthetics potentially, but it does create could potentially create a nice aesthetic there. So my curtain sunshade doesn't look particularly nice. I haven't offset my adaptive point in a nice way. I've just done it pretty quickly there. So yeah, that could be driving almost any instance parameter in Revit. So we could be looking at the color of the glass or the reflective value of the glass. We could be looking at almost any instance parameter within the family that we're driving with these results. So really powerful tool is Dynamo there. So I am almost done now. That's kind of all of the practical type exercises I had to go through. The question came up yesterday actually at the BIM Day Out about using it structurally, and actually I haven't got any examples. But yeah, very powerful tool, Dynamo, to be driving Revit structural elements, and on the the logic and on the form creation side, just a really powerful tool that if we're creating these mass forms and some of the interesting looking forms that I said I wasn't going to be talking about earlier, in software, rather than creating it visually and aesthetically potentially, and then attempting to rationalize the form after the fact, with Dynamo we're really using math and formulas to do the initial form creation. So it doesn't get much more rational than that. So it can potentially, with the right process in place, eliminate the need to rationalize a form after its creation for the early concept sketch design, because if the form is created on a rational, on a logic, then yeah, you don't get much more rational than that later down in the process. So yeah, that was kind of all I had to cover with Dynamo there. If you haven't got it installed, it does come installed with Service Pack R2, I think, with Revit, the latest one there. It will download Dynamo version 7.2 automatically there. If you do want to work in the old version for some reason, there's a lot of workflows around for the old version as well. You actually need to uninstall 7.2 if you've got it installed. Install the 6.3 and then install 7.2 over top, and that will give you this little Dynamo switcher here that I can switch next time I open Dynamo Vasari or Revit. It will switch to the other version of Dynamo when I click the big Dynamo button. So that would be that's a goodie there. If you don't have Revit on there yet, or you don't have Service Pack 2, the web is DynamoBIM. There we go, dynamobim.org. So that is the website, the main website there, where you can get the package. Really great, a groundswell really of support for this package being an open source. There's a lot of great advice here in the blogs and on the website, and just great open source community ready to help. When I was just learning some cases where just got stuck and trying to get an understanding of and some help there, and just instant replies overnight from some top guys in the States, Zach Cron and whatnot, replying personally to myself. It was just really great community around the product. So I recommend getting active on the blogs and whatnot if you're getting into that, and that's a great spot for support and whatnot. So that is all I had to go over. Maybe I haven't put those work sets up anywhere at this stage, but maybe on my blog at some stage if I get them uploaded. ultrabim.blogspot.com.au. Sorry about the stupid URL, but it was kind of the last BIM URL left on the planet. Yeah, keep an eye there. I might try and throw some of these Dynamo workflows up there for you to download. But yeah, if you've got any questions, I'll go through the questions now. Thanks very much for attending. Oh, here we go. It's a funny question. No, it's not. It's just someone saying hi. Attendees questions. So no questions on there as yet. All right. No questions. We finished up 5 minutes early. Thank you very much, everybody, for attending. And this webinar will be available on our website, on the A2K webinar vault. So under the events, we go to webinar vault, and there's the all the other webinars that have happened recently. I recommend checking out that augmented reality one too. That was heaps of fun. So yeah, jump on there, and in about a week's time, this webinar should show up there. Thank you very much for attending.